Assalamualaikum warahmatullahi wabarakatuh and a very good afternoon. My name is Izzati Binti Ahmad Kamal and my metric number is 276920. Today, I'm going to present about the solution for question 1 in assignment 5. So for the first question, we need to determine the function where there is a concave upward and where is the function is concave downward. So first, we need to differentiate the function fx equals to x cubed minus 6x squared plus 18x minus 15 to get the first order derivative, which is 3x squared minus 12x plus 18. And we use the formula which is d dx xn equal to nx power of n minus 1. And we differentiate again to get the second order derivative, which is 6x minus 12. And then to determine where the function is concave upward and where is the function is concave downward, we solve the second order derivative by equal to 0 to get the value of x. So we get the s equals to 2. By testing the intervals to the left and right of s equals to, for the second order derivative function, we find that function smaller than 0 on negative infinity 2 and the function bigger than 0 on 2 positive infinity. Hence, when the function of second order derivative is smaller than 0, it shows that the function is concave downward on negative infinity 2. And then when the function is bigger than 0, it shows that the function is concave upward. Then we move to the B question. So in this question, is given the cost function for a manufacturer. So describe the behavior of the marginal cost function. In this question, we need to find the marginal cost function and describe the behavior of marginal cost function, whether concave upward or concave downward. So for the first question, the marginal cost function is obtained by differentiating the total cost function. So we use the formula d ds x power of n equal to nx power of n negative 1. So we get the total cost function with c prime s equals to 0.000003 x squared minus 0.006x plus 5. So for the second question, to determine the marginal cost function, whether concave upward or concave downward, we differentiate again the marginal cost function to get the second order derivative. So we get 0.00006x minus 0.006, and then we solve the second order derivative by equal to 0 to get the value of x, and we get x equals to 1000. By testing the intervals to the left and right of x equals to 1000, for the second order derivative marginal cost function, we find that the marginal cost function smaller than 0 on negative infinity 1000 and the marginal cost function bigger than 0 on 1000 positive infinity. Hence, when the second order derivative marginal cost function is below than 0, it shows that the marginal cost function which is 0.00003 x squared minus 0.006 plus 5 is concave downward on negative infinity 1000. When the second order derivative function is bigger than 0, it shows that the marginal cost function is concave upward on 1000 positive infinity. Alright, then we move to the next question. It is given the revenue function in ringgit Malaysia, which is 2x cubed plus 40x squared plus 8x, and the cost function in ringgit Malaysia, which is 3x cubed plus 19x squared plus 80x minus 800. So we need to find the level of production that will yield a maximum profit for the company and find the price per unit to maximize the profit. So, what are the solutions? To solve this question, we need to use the formula, which is profit function equals to revenue function minus cost function, and then we substitute the function into the formula, and then we get the answer, which is negative x cubed plus 21x squared negative 72x plus 800, and then we differentiate the profit function to get the negative 3x squared plus 42x negative 72. to find the level of production that will yield a maximum profit for the company, we determine the stationary point of the profit function, which is P prime x equals to negative 3x squared plus 42x negative 72 but equal to 0. This is quadratic equation and so can be solved using the formula. However, before doing so, it is good idea to divide both sides by negative 3 to avoid large number. The resulting equation has a solution and then we get 12, 2. To classify this point, we need to evaluate the second order derivative profit function by 12 and 2. We substitute 12 and 2 into the function and get negative 30 and 30. 30 is reject positive. The second order derivative profit function is below than 0 or negative when x equal to 12. Thus, the level of production that will yield a maximum profit for the company is when x equals to 12. And then we move to the next question, which is to find the price per unit to maximize the profit. We use the formula which is TR divided by Q, and then we substitute the function into the formula and get the price per unit to maximize the profit, which is 776 or RM776 per unit. I think that's all from me. Thank you.